Hello everyone, my name is Srushti Siddharam Birajdar. Currently I am studying Computer Science and Engineering from Sri Siddheshwar Women's College of Engineering, Solapur. Today we will see an interesting and important topic of basics electrical and electronics engineering. We will see that what is the principle of moving coil and moving iron, what is the functioning and what is the difference between moving coil and moving iron. So let us start. Now let us see the working principle of moving coil, that is permanent magnet moving coil PMMC instrument. The PMMC instrument is the most accurate type of DC measurement. Principle of working. Motor principle Lorentz force. When a current carrying conductor, the moving coil, is placed in a strong uniform magnetic field, it experiences a mechanical force resulting in a deflecting torque, that is TD. Now let us see the mechanism of moving coil. A permanent magnet provides a fixed radial magnetic field. The current to be measured passes through the lightweight coil wound on an aluminum former, creating an electromagnetic field. The interaction between the coil's magnetic field and the permanent magnetic field produces a torque that causes the coil to rotate. The controlling torque TC is provided by the two phosphor bronze hairsprings, which also serve as current leads. At the final steady state deflection theta, that is TD is equals to TC. See the torque equation and scale. Deflecting torque TD. TD is directly proportional to I. Deflecting torque is directly proportional to the current. Controlling torque TC. TC is directly proportional to the theta. Controlling torque is proportional to the deflection. Since TD is equals to TC, it follows that theta is directly proportional to I, which is the current. Now, what is the result? The scale is uniform, linear. Now, what are the limitations? Only a suitable for DC. If AC is applied, the current and torque rapidly reverse direction, and the pointer cannot follow the rapid oscillation, resulting in a reading of 0. Now, this is the diagram of galvanometer. Here you can see that the galvanometer consists of a moving coil. Let us see the working principle of moving iron instruments. A moving iron instrument is a versatile type of used for both AC and DC measurements. Principle of working. Magnetic induction and a force of attraction, repulsion. An unmagnetized soft iron piece is placed in the magnetic field of a current carrying coil, causing it to be magnetized and moving. Let us see the mechanism. The current to be measured flows through a fixed coil which acts as an electromagnet, creating a magnetic field proportional to the current. This field magnetizes the soft iron vein inside the instrument. The resulting force, attraction or repulsion on the iron vein produces the deflecting torque, that is TD. The controlling torque TC is provided by spring control. At the steady state deflection theta, TD is equals to TC. TD is a deflecting torque and TC is the controlling torque. Now let us see what are the key types. Attraction type. A single movable piece of a soft iron is attracted into the hollow fixed coil where the magnetic field is strongest. Now let us see the repulsion type. Two soft iron veins, one is fixed and one is a movable, are placed inside the coil. When the current flows, both are magnetized with the same polarity and thus they repel each other. Let us see the advantages and disadvantages of moving iron instrument. Universal use. These instruments can be used for both AC and DC. Less friction errors. Errors due to the friction are quite small as torque weight ratio is quite high. Cheapness. A single type of moving element could cover the entire range in a one reason that moving iron instruments can be quite at less cost than some other types. Roughness. The instruments are roughest owing to simple construction and also that there are no current carrying parts. The instruments are capable of giving an accuracy within the limits of both precision and industrial grades. The scale of moving iron instrument is not uniform and is cramped at the lower end. These instruments are subjected to serious errors due to the hysteresis, frequency changes, and stray magnetic fields. Let's see the difference between moving coil and moving iron. The working principle of motor principle works on a current carrying conductor in a magnetic field, and in moving iron it movement of a soft iron piece in an electromagnetic field. It's suitable only for a DC measurement, and moving iron is suitable for both AC and DC measurements. In a motor, deflecting torque TD is directly proportional to I, and in a moving iron, the TD is directly proportional to the RMS current. The uniform or linear scale is used in a motor principle. Non-uniform or squared scale is used in a moving iron. And what is the accuracy? Principle, the motor principle has a high accuracy and sensitivity, and a moving iron has a less accurate and less sensitive. Operating field provided by a permanent magnet, and in moving iron provided by a fixed electromagnet coil. Low due to the strong permanent magnet field, and high to generate the required magnetic field. Eddy current damping effective and fast. Air friction damping is similar in construction, and it does not occur. No ferromagnetic material in the moving system occurs due to the magnetization and demagnetization of the moving iron piece. Construction more delicate and complex, more robust and simpler construction. Thank you so much for watching.